Hi, everyone. The next episode of Office Hours is here. Today we have Nuno from Gateway Labs and Miguel from Nillion. Let's begin with the quick introductions and some background on the project. Nuno, you want to start?
Yeah, absolutely. Happy to be here. Nice to be meeting you guys as well, and thanks for inviting me. So I'm Nuno, one of the co-founders, and I lead everything engineering related here at Gateway. What Gateway is doing, I'll save like the sweet spot for like more for the end. But what we are trying to do is to bring privacy and unified states to blockchains in order to actually bring more use cases, more composability to to the blockchain space as is.
Hey
And
everyone.
Miguel?
Yeah, my name is Miguel. I'm co-founder of Nillion. And essentially what we're building is a new type of decentralized infrastructure that can handle private information so that you can put that sitting alongside a blockchain and you can run and store all the private information, all the private data that you have on this infrastructure. It is decentralized, so it has the same look and feel as you would expect from a decentralized network, but it specializes on handling these type of computations and storage operations, and then it seamlessly interconnects as well with blockchain technology.
Okay, so when it comes to privacy, I think there are several active areas of research, or I guess some of them are much closer to production than others that people pursue. So I would be interested to hear how you guys think about it. Like, what trade-offs do you see? What approaches you pursue? I guess let's go in the opposite order. Miguel, you want to start?
Yeah, so essentially we think that privacy should be tackled from the standpoint of privacy enhancing technologies, which is it has been there's been along for 40 years or so, but now is the first time that they're really production ready, and that's kind of the core baseline of our infrastructure. But we also at the same time believe that there's no single silver bullet. There's no PET that will elbow out the other ones, and so that's why our approach is rather to build a sort of orchestration layer that is able to interconnect the different PETs so that we can offer our developers the best possible point in the trade-off space regarding the requirements around security and performance.
Yeah, I would say something similar in the sense that like privacy has been a concept since forever really, and now that we are seeing like computers and technology evolving to have several different ways of tackling the issue. I think it's not a matter of finding one silver bullet, but rather like tackle the actual problem. How can we keep stuff private and how we can use that or how we can put that in the public eye, so to speak, while preserving the privacy. So we are doing something quite similar in the sense that we want to use technologies that actually scale for millions of users and for various use cases, but we are not like saying that this is the way and all the others like are terrible technologies. On the contrary, we think that there is space in the industry to attack privacy from multiple angles, and I think like there will be space for everybody to win a little bit.
And on that front, I would add that I don't see like Gateway or ourselves like competitors. I think privacy is competing with other narratives in the space. Like so, for example, there are other narratives that it's they're all about making it faster, making it more scalable, but it's the existing technology. So privacy opens up a new dimension in terms of use cases you can tackle, in terms of growth for the industry. It's more like a disruptive approach compared to the more incremental approach that other narratives offer. And in that sense, I completely agree with you, Nuno, that we're kind of on the same page. We're trying to push forward privacy because I think, all believe that it's an important ingredient that is missing in Web3.
So when it comes to privacy, I think the way I think a lot about privacy from perspective of using it with emergent large language models, right? So they require For some other use cases, I think privacy is easier. Like anything that just requires exchange of messages or files, I encrypt it on my end, you decrypt it on your end, and for quite a few use cases, you can achieve, complete privacy with relatively little effort. Like messaging, document sharing. But when it comes to using things like large language models, it's more problematic because given majority of people cannot host a large language model, they have to effectively send the prompt to the machine that hosts the large language model, right? So you either send it to, like not even touching aspects of whether we should trust sending our data to Anthropic and OpenAI, more relevant to our use cases. If we have decentralized networks of inference providers, we definitely don't want to send our prompts to those guys, right? Because that's completely random people living on the internet. And when I think about it, I primarily think from perspective of using TEs, because TEs they don't require any advanced technology. Like there is no cryptography involved that is bleeding edge. They work relatively fast, but they have an obvious drawbacks, such as A, you still have to trust a big player, and B, in the past, previous generations of key technology have been in different ways shown to be broken, right? So with every new technology, they might not be shown to be broken yet, but the trust, and maybe they are fundamentally unbreakable, but the trust has somewhat eroded, right? And there are many people who would not be comfortable with the keys. So I would like to hear your thoughts on where TEs fit in the picture, where we should not be using TEs. If any of you guys use FHE, how far FHE has come, and if you guys use MPC, what MPC works for, what it doesn't work for. So pretty open-ended question and pretty generic, but I would be interested to hear your opinions here.
Who
Yeah,
starts?
I can start. I think like these have their own merits to what they want to tackle, but as Miguel mentioned, like it's not a silver bullet, and I think like as you mentioned, Alex, as well, like it comes with a lot of drawbacks, especially because like if you have control of the TE in the physical environment, you can easily like attack it via side channel attacks. So it's not the standard that you want to have when dealing with such sensitive data, and especially for AI and God knows what you end up putting on the models, right? So for that, like I think TEs might be complementary for other pieces of technology that might evolve. You mentioned FHE, you mentioned MPC. In particular, MPC is something that we are strongly building here at Gateway in the sense that we believe that MPC, with more recent innovations, more recent research, has shown to be scalable for the type of workload that we want to target, especially when it comes to AI, especially when it comes to model training, especially when it comes to private inferences on sensitive data. So TEs could be simply like a piece that enables like these multi-party computation servers to run, while not being like the core piece of the entire technology. They can still play a role, while the big piece is instead like the MPC technology, which will allow you to put the data in a privacy preserving way via linear secret sharing or garbled circuits or whatever scheme that you want to use there. And then you perform the computation in a completely private way, completely preserving the user's privacy. Applying that to AI, you have, not now because it's not yet there, but in the future you might have like large language models running in a completely decentralized and sharded way, so to speak, with data that is also sharded across multiple computers. And to like close the circle, you have TEs that can just be powering up everything to add an extra layer of privacy to ensure that everything end to end is completely or almost unbreakable.
Yeah, I completely agree. We see TE as another tool. It's the right tool depending on the degree of sensitivity of the data that you want to be using in your application. For some applications it's fine. For some others it's not. And we see the distinction between TEs and other software-based privacy enhancing technologies like FHE and MPC, not as a binary decision. I think it goes along the lines that you were mentioning, Nuno. I think both can be combined, even in the same solution, in the sense that you can, for example, run some layers of the LLM inside of a TE, some other layers inside of MPC or FHE. Even you can make distinctions and run linear layers inside of MPC or FHE because it's more performant. And then the non-linearities like activation functions or normalization layers, you can run them on the TE. There's various combinations and approaches to this. That being said, there is, of course, a performance gap between MPC and FHE that needs to be bridged. And so we've done a lot of work on that front. What we did is to take technology to kind of borrow it from signal processing, in particular the discrete wavelet transform, which is used to compress signals. For example, is used in the JPEG 2000 standard for image compression. And we ported it into cryptography, both for FHE, for TFHE in particular, and for MPC. And we saw great improvement, so significant improvement in the evaluation of the nonlinearities, because you can represent them as a lookup table and then you can compress that using these techniques. So, and when you look backwards, you see that in the last 5 years of development, we've gone all the way from evaluating your models with 1,000 parameters to now models of 1.6 billion parameters. So there's been a lot of improvement and will continue so, I believe. And so the bridge, the gap that exists between TEs and other software-based PETs, I think will get closer and closer. And also, we have an experience, like we've tested both FHE and MPC, and we kind of concur with you, Nuno, that MPC seems to be more performant, particularly when you're working with a few parties than FHE. But it does have, on the other hand, the disadvantage that you have to pre-process information ahead in time, something that you don't have with FHE. So again, it really, really, really depends on your use case and application.
Yeah, and just to add like a small note on that, I completely agree with you. Like it's a matter of you have all of these tools on your tool belt, and it's a matter of like deciding which ones you want to use for particular use cases. We are big believers in like mixing and matching all of these different primitives. So for example, as you mentioned as well, like if you want to use MPC for a particular piece of the puzzle and then TEs or both, or and then like the outputs, you want to take them and you want to share those outputs securely with another party via, I don't know, something like proxy encryption. Like the fact that we are walking towards a future where we have all of these primitives that before were like super uh, kept by academics, so to speak. Now that we are walking in a direction where we have all of these at the distance or at the click of a button or at the distance of an SDK, it really enables like all of these different companies, all of these different new use cases to emerge. And it's just a matter of mixing and matching and building whatever you want, really.
And I think that's a key ingredient that you mentioned right there, which is the fact that this no longer is, pertains to the domain of pure academic research. There's a lot of commercial institutions. For example, this work that I was mentioning before, we did it in collaboration with Meta. I think we've reached a point where we're kind of the protagonist of this era of PETs, of this stage, is the engineer, is the kind of applied cryptographer that is able to take that theoretical work and actually implement it at scale. This wasn't the case before. Like 5 years ago, we were still in the stage of developing the theory and kind of testing and coming up with new protocols. Right now is more about taking those protocols and implementing them at scale.
What is so the thing you mentioned with Meta? It's called Nillion, right? What's the exact semantics of the?
So our platform is kind of divided in three main, what we call blind modules. So one is the general purpose compute module currently under MPC, that is called NilVM. Then you have NilDB, which is the general purpose module for the storage at scale of information in a privacy preserving way. And then the Nil AI is the one that encompasses all these innovations that I've been talking about. Is the one that where you have the TEEs, where you have the MPC and all that all that kind of soup of technologies that can be combined in different ways and forms. And then on top of those is where you build what we call SDKs. For example, you can build private racks by combining the database product that you use to store the embeddings, the vector embeddings, and then Nil AI, which you use to compute the distances and to compute the shortest one and so on. So that's in the combining those three products is when you build the SDKs that provide then inference, provide private rack applications and stuff like that.
So we have this completely unrelated to privacy product called not product, but component called chain signatures, where you have a multi-party computation that signs transactions on other blockchains, and we plan to introduce their TEs. So I think TEs and MPC work very well together in the sense that if all the computations of every party in the MPC happens inside the TE, then if in fact people execute side channel attacks, you still get the whole security of MPC. And in the absence of side channel attacks, someone who corrupted post factum a large percentage of the parties will not be able to do anything at this point, because once the computation has completed, the side channel attack, I guess, is meaningless, right? So I think it's interesting. I think one thing that would be interesting to say explicitly is what are the security considerations of each of the approaches, right? So my understanding is that with TEs, with TEs, we already sort of mentioned them. There are side channel attacks, presumably. They have been shown to work pretty well with SGX. I don't know if side channels attacks have been actually shown to be effective against TDX. They have some mitigations. Then FHE, if my understanding of FHE is correct, then as long as cryptography is sound, then there is no external event can result in me losing, my data being exposed, right? With MPC, depending on the configuration, if sufficient number of parties collude, my data will be revealed, right?
Yeah,
is my understanding correct here?
It's a bit more nuanced than that, I would say, because, for example, there is two forms of security mainly in cryptography. One is semi-honest security, which means that the parties cannot, or the nodes running the computation cannot access the secrets, but they can tamper with the result from the computation. And then you have malicious security, which is when you're even able to, account for that, and you're able to counteract that type of attack. With FHE, it is more expensive to do the latter, because it essentially means that you have to repeat the computation across many servers and then compare the results, or you have to do a zero knowledge proof of execution, which is also very expensive to run on top of FHE. So it is true that you don't have the collusion problem, but you do have that other problem with MPC can be accounted for, because you do have malicious security in MPC.
I see. Okay, so with FHE, if I delegate to someone else to do the computation, I know for sure they will not see my data, but without redoing exactly the same computation or having some other cryptographic proof, I have no idea if they actually did the computation correctly.
Exactly. They could be running another computation.
Mm-hmm. Makes sense.
Yeah.
Yeah, and a note on that as well, like as it pertains to MPC. The fact that you send off your data in a sharded rather way, it means that like the data won't be accessible by other nodes as long as they like are in the honest majority scheme. But on that note as well, like if they are in an honest majority scheme, if the majority of the nodes collude, then you can tamper with the results of the data, not necessarily with the inputs per se. with the malicious, you can like counteract that. So because it's malicious, the nodes are configured in such a way that they cannot, or I wouldn't say cannot, but like the system ensures the confidentiality, ensures the correctness of the computation, and obviously like the sanctity of the inputs. So it's more secure than just normal like honest majority schemes, but in both cases like the inputs, granted that like they are properly sharded and no party in the middle like is able to extract the shards or the mask or anything like that, everything is kept secure.
Right, but it is the case. Like I think this is where the difference is with FHE and MPC, is that if I don't trust anyone at all, so I think it's important. It's similar to let's say Zcash, right? So with Zcash, there are two goals that the protocol pursues, right? One is that when I send money to someone, I need to be sure that nobody ever knows that I did it, right? And the second thing is that I would prefer the money not to appear from nowhere, right? And in my majority of cases, the former is stricter, is more important than the latter, specifically in the privacy preserving cryptocurrencies, in the sense that, yeah, if like effectively ZK snarks can have two different or like not ZK snarks specifically, but technology that provides privacy on top of which you might build a cryptocurrency like Zcash. It provides you two guarantees. One is that data that went in, like ZK part that went in, is not visible, and the second one, the argument of knowledge part, is that it is in fact sound, and the statement it attests to is correct, right? And I think the failures in the former is quite unlikely. The failure in the latter is, there were bugs in the past which would allow you to create a snark for something that is not true, right? But the failures that you get are different, right? In the former case, your data leaks, and that could be way more disastrous for some entities than losing money that were sent, right? So I think here this is similar, right? So when I'm sending data for inference, it's one thing. It's different levels of risk for me for that data to become visible to someone else, right? Like imagine I'm sending a data that can be used to blackmail me eventually, right? And it's another risk if the response from the model is tampered with, right? So my understanding is that with FHE, the former, assuming the cryptographically sound and there is no bugs, the former is impossible, right? No matter how many, even if the whole world colludes against me, right? It's impossible to get my data, but it is very, it's possible to give me garbage out, right? To give me a response which is completely incorrect, right? So against which I can, in some way or another, try to, like again, I can send it to multiple people. Of course, again, if the whole world colludes, all bets are off. But in case of MPC, if my understanding is correct, that then no matter what you do, if everybody colludes against you, if every single node in the multi-party computation is malicious, both are the case, right? Both the data will be revealed and the output will be tampered with, right? So from this perspective, I find FHE to be stronger. I don't know if that's how other people look at those technologies, like if this is a meaningful
Yeah,
threat
I
model.
would say for most cases you're right. I would use as a counterexample threshold signatures, which you mentioned before, which typically run in a dishonest majority setting, whereby if you as a customer are one of the nodes, then even if all of the other nodes collude in MPC, we're talking about, they wouldn't be able to reconstruct your private key. So there are settings, dishonest majority settings, where that doesn't happen, is not the case, even in MPC. But you're right that in FHE, you are protected by the hardness of a cryptographic problem, which is learning with errors, which is thought to be quantum resistant. And so, which means that essentially if you gather and harness all the power on Earth, you wouldn't be able to crack that. in MPC, you usually get that guarantee, or even stronger. You get even information theoretic security for the share that you're getting as an individual, as a party, but you don't get that guarantee when you kind of look at the shares together. If you're able to corrupt multiple parties, then you enter this other discussion of what is the threshold that you're using in the scheme.
Yeah, and to add on top of that as well, like as the example that you gave, Miguel, about you running a node and you are part now of like this committee that executes the computation. That is a way in a dishonest majority in a malicious setting of like almost guaranteeing that everything is going to happen your way, because like you are the client, you are the person like executing or asking for the computation to be executed, so it's in your best interest to, well, not collude with the others, I would argue. And to also like do a full circle here with what you said, Alex, like I think for different things, different primitives might be used. I think like especially for example with MPC is interactive in the sense that like you need to be here to like send your data, shard your data, and then like execute the circuit or the computation based on that data. That's more aligned with the entire ethos of blockchains as they are. Things don't really happen automatically, like without the click of a button or with a cron job happening on chain. Everything happens, or all the triggers that might be automated, they happen on chain, but you need to still trigger on chain actions to happen, which is more aligned with the entire ethos of being interactive, therefore like implementing an MPC scheme to do computations like that. FHE, you could like look at that as a non-interactive standard where, for example, you can encrypt healthcare data, keep it there encrypted, run computation, just keep running computations, and like because it's non-interactive, you don't really need to be there 100% of the time. Let's put it like that. So yeah, to this point, it really depends on what you want to do, what type of data is, where you are using this technology. Is it blockchain? Is this outside? Is this AI? We want to shard this across multiple people. We want to put this on a server and call it a day. I mean, there's no single silver bullet.
Yeah. So
and I would
that
add to add that,
go ahead, Miguel.
yeah, thank you. I would add to add that actually those technologies are combined, right? So in some setups of FHE, you thresholdize the private keys, so they're kind of secret shared amongst many parties, and that's a technique typical of MPC. And also in other techniques, both in MPC and FHE, you use ZKP to make sure that the inputs satisfy certain conditions, that there's no overload, or that the inputs are within certain range. So that's, I guess, what we were saying before, Nuno and I, that all these technologies are not like binary or trinary. They can be combined really at a deep level of interaction, and you get a result that is actually better than any single one of them separately.
But for me to fully understand, right, and this is purely theoretical, but let's say that we have a technology that allows you to run. So I generate a private key locally, right? So the key pair I have full control of, and then we have FHE that is sufficiently performant to be used, right? So like to do the inference, and then we have sufficiently performant scheme to compute a zero knowledge proof that the computation is correct, right? Would that have any so if we have that construction which is performant and usable, what advantages, if any, MPC would have on top over it?
Well, you would have to thresholdize the private keys, so that there is no single element or entity in your whole equation that has the power to decrypt the information in that server. So that now we have.
What if only I have the private key?
Well, if you the user.
Yeah. I'm the user.
You could have that as well, but again, you have the problem of owning that piece of information. The client is typically not the best place to store that sensitive information, so it rests better in kind of server infrastructure, controlled and maintained by professionals. But you can see that in your example, you've already kind of mixed the three of them, because we've concluded kind of that thresholdizing would be a good idea. Then you used ZKP as a proof of execution and FHE for running. I would say The problem with your with that scenario is that, if you mix FHE with ZKP on LLM inference, it's not going to be performant. That's the
Yeah, of
problem.
course. That was more of a theoretical
Yeah.
thought experiment, right? If they were performant, yeah. But I guess then my next question is, so now let's for a second concentrate on MPC. How performant is it today? Can we use it for LLMs, or do we primarily use it for other forms of machine learning? And what is the well, let's begin with how performant they are, and then I guess my follow-up questions will depend on the answer to that question.
Yeah, I think I can answer the last question. Can we use that for LLMs? And the answer is no. I mean, at least not at scale, at least not with the same speed that you see on ChatGPT. Uh, you could, in theory, build like an MPC circuit that would compute like that LLM for you, but that would take an enormous amount of time. Point is like how fast it is today. We've been running some tests and like we've been implementing some of the most recent optimizations that you see in academia, and for uh, like normal arithmetic Boolean circuitry, you can get really interesting results. Compared directly with TFHE, to give you an example, we can see like results that are 16 to 25, if my numbers are not mistaken, 16 to 25 times faster. So at scale, for something like, for example, a blockchain where you are not going to run an LLM right now, at least, you can put, in theory, uh, thousands of TPS compared to at least the current iteration of fully homomorphic encryption. As for machine learning and AI, the way that we see the technology is evolving is that all of these can become the plumbing or the pipelines for providing better and faster machine learning. Uh, if you think about like today running an NLM with, or run any sort of like model, decision tree, like anything that comes to mind with private data, the only realistic option that you have are like TEs or like enclaves running on GPUs. I believe NVIDIA has like some product offerings in that regard, which are heavily controlled. If we evolve towards a world where all of these can be properly sharded, like the data that you pass, and you can have like execution times that guarantee that a model can be converted into an MPC scheme and be properly computed in whatever scheme, like honest majority, malicious, although malicious is a little bit harder, but let's say honest majority. You can, in fact, bring like complete decentralization to the entire execution, complete privacy to the entire execution, because like now everything is properly sharded, no one has access to the data. You can pass that to models, and now you can train models, you can run inferences, and you can enable a lot of use cases. For example, medical use cases. For example, collateralized loans with real world assets that you might not want to make public. The sky is really the limit.
Yeah, we're seeing similar numbers. I think the state of the art for LLMs under MPC, for example, is that around 1.6 billion parameter model, which is small GPT-2. It runs around a second per token, which is very slow if you compare it to kind of plain text. It scales up linearly, though, with the size, which is good, but it's sufficient. I mean, it's clearly not enough. If you compare that to TEs, where you can run Llama 7B up to 70B, maybe, with a penalty in performance between 1 and 10%, that's kind of a different ballgame. So that's why it really depends on your security requirements. If they're more stringent than what you can get from TEs, then I think the solution is to combine. Combine both approaches, as I said before. So some layers can run in MPC, some layers can run in TEs. But still, given those constraints, you can also do other things around LLMs. For example, you can build a private rack solution that can then fit into the TE execution, like inference part of the solution. You can do synthetic data generation. You can do, even on the training side, you can do the combination of weights from federated learning under MPC, so that no one sees those weights coming from the different computers training the models. And you can do, for example, I think you were referring to that, Nuno. You can actually work on the data sets. You can normalize them. You can kind of aggregate them under MPC as well. In essence, it becomes like a tool set that where you can start chunk by chunk, providing more and more privacy into the equation. And of course, there's going to be always this push between what can be done and what needs to be done. But as I said before, this is a fluid limit that is moving very fast in our favor. And I would also say very briefly that I think also there's applications coming into the future where you can wait a little bit. You can see that already with some agents, where you hand over the task and you wait for a few hours for the agent to do research. You have more patience because the LLM has more autonomy. So that plays in favor again of privacy preserving solutions, even though they're slow, because the LLM is becoming more intelligent. So you're willing to give it more time to come back with a meaningful result.
Yeah, I'll just add like a small note on that as well. Like, just because we are not at the stage right now where we can realistically run like large language models with a lot of parameters, it doesn't really invalidate that we can't do other things on the data, as you were just saying, Miguel. I think that like if you consider that TEs can pre-process, post-process the data, as well as MPC, as well as FHE, as well as, for example, creating data lakes where you can have, for example, the data or your user's data encrypted, sharded, just the data sets there. You can retrieve them like using threshold cryptography as well. And then the combination of all of that, you can create actual prompts or data sets or whatever you need to insert into like the models for inferences or for training. So we are at the stage right now where the technology already exists to facilitate and to bring a certain degree of privacy to AI, but we want to be in a position where all of the pieces of this equation, gathering data, processing, actually running the inferences, and then getting the results, everything happens in a completely private way, whether that's with MPC, which is what we are working towards, or any other technology. We'll be here to see, but we are already at the stage where you can do some really cool things with the tech we have.
And I'm curious to hear what are the sort of in the short term, like let's say the next half a year to a year, what are the biggest use cases that are enabled by MPC that you guys expect to see being deployed in production?
Yeah, so I can briefly touch on that. I think that like if you can bring fast private execution with unified state on chain, you can like actually have private data as a default in the way that you interact with chains. So you don't need to, I don't know, use a co-processor mechanism to send your data, process whatever you want, and then send it back, or do encryption on like off chain, send on chain, and do some weird things. What you can actually do is like make both private as well as public data coexist in the same space, be treated as one, and that enables like a lot of use cases. Let's say, for example, we can prevent MEV to begin with. We can do like private DeFi. That's just one that comes to mind, as well as like confidential transactions. The sky is really the limit. Like everything that you can do on chain today using like normal Solidity, whatever code, whatever like programming language you use, if you bring that to a space where everything is by default encrypted or secret shared, you can like put more sensitive pieces into the chain and do as you wish with that. That's the
On our end, we're seeing a lot of traction from developers building data analytics solutions where you can kind of send your data over to this decentralized database, and then you allow for other third parties to perform computations to get insights from your data, probably or possibly mixed with other customers' data. So this falls within the data to earn kind of business model, or also even data to access. And also the interesting thing is that this nicely connects with AI, because some of those computations that people want to run on your data have to do with AI. So there are actually AI models that run with various degrees of complexity. We're also seeing people building marketplaces for private agents, and we're also seeing people build DeFi solutions, like you were saying, Nuno, for example, encrypted order books, private auctions, private limit orders, or private liquidation auctions, or private trading policies. And also there's people building on-chain games whereby you want to keep the private state of the game secure or secret, and so you outsource that over to privacy network like the blind computer from Nillion. And then the game continues on chain, and it kind of gets that randomness and makes use of it. But this time you have the guarantee that no one is tampering with that generation of the randomness, so that you cannot gain advantage by designing the game. You can protect your users against yourself.
Cool. Okay, I think we're getting close to the end of the office hours. As the closing thoughts, I would be curious, guys, to hear your thoughts about what is. Well, I guess one question is, will NPCs and FHEs catch up to run large language models? If not, what will be the future of those? Are we forever stuck with TEs, or will there be another solution? And generally, how do you see the world, like the privacy landscape, shaping up longer term, like let's say 5 years from now?
Yeah, that's a really interesting question. I think like if we don't catch up with TEs or normal execution, then we fail as an industry, like just to summarize. But in a more serious note, like I think because of the resources, because of the interest that all of these technologies have been getting over the past few years, the natural course of events is that like everything ends up being improved such that running like large language models in a decentralized setting will be the norm in a few years. At least that's what I want to work towards, and I believe like Miguel would be of the same opinion. And as for getting stuck with TEs, I mean, again, TEs are good for some use cases. I don't want TEs to be the norm. Like, I don't want just MPC to be the norm, or FHE or anything really. We want to have like all of these technologies at the stage where they are fast and performatic enough such that they can run really anything that we want, including large language models, AI agents, like process the data, do everything that we've been talking over the past hour. And then like you just pick and choose based on your criteria whichever you want to go with. That's the goal.
Yeah, I think we will see deeper integrations between TEs and MPC. For example, MPC can help out also with key rotations inside of the TE to make them more secure. And as I said before, we will see those hybrid solutions whereby you can mix some of the layers inside of the TE, some others inside of MPC or FHE. So it won't be that much of a switch, on-off switch between TEs to MPC. MPC and FHE, I think it's going to be closing the gap, but I don't think it will ever be kind of completely breached. But we will reach hopefully a point where it really pays off to run the largest part of your load inside of MPC. And yes, then that maybe those nodes, those MPC nodes, can run also inside of a TE for additional protection, but TE wouldn't be like the main source of security. And then privacy in general, I think it plays a major role in opening up the space for decentralized AI. I don't think decentralized AI can exist without privacy. Without that, you just get the verifiability part of things, which is, okay, I get the guarantee that this model actually run and not a cheaper one. but you don't get privacy, and things are going to get really, really sensitive when those models start, interacting with you in a more personal way, and you start sharing your tax declarations and your finances and your health records, and start treating those models as your personal therapist. So that's a big red line for decentralized to go forward without privacy. And at the same time, it's a great opportunity for privacy to actually grow and allow decentralized AI grow beyond its current limitations. And in general, also that applies to the larger Web3 space.
Awesome. Okay. Thank you, Miguel and Nuno, for joining us today. And see you, everybody, at the next episode of Office Hours.